Hi everyone, and welcome to my video on mathematical proof by contradiction. In this video, I'll be going over the basics of proof by contradiction, and then I'll work through 3 examples. So what is proof by contradiction? Well, proof by contradiction is a type of mathematical proof that starts by assuming the opposite of what you are trying to prove. If you can then show that this assumption leads to a contradiction, then you can conclude that the opposite of your assumption must be true. So let's start with the first example. We are given that P is even and Q is odd, and we want to prove that P plus Q is odd. So the first step in any proof by contradiction is to assume the opposite of what you're trying to prove. So in this case, our assumption is that P plus Q is even if P is even and Q is odd. So now we need to show our workings. And we can let P equal 2n. So this must be even. 2 times any number must be even. And then we'll let Q equal 2m. So m is a different number than n plus 1. So an even plus 1 must be odd. So we have our P is even and our Q is odd. And now to work out P plus Q, we add the 2 together. So we have 2n plus 2m plus 1. And we can factorize out these two to make 2 lots of n plus m plus 1. And because you're multiplying n plus m by 2, this by definition must be even. And when you add 1 to an even number, you get an odd. So now we can write that this means that P plus Q is odd, which contradicts the original assumption that P plus Q is even. Therefore, if P is even and Q is odd, then P plus Q must also be odd. And when we create a proof by contradiction, we need this final paragraph to conclude our findings, okay? Let's move on to example 2. And in example 2, we've been asked to show that there exists no integers, which we'll call a and b, for which 18a plus 12b is equal to 1. So our assumption then is that there does exist integers a and b such that 18a plus 12b can equal 1. So now we need to show our workings, and we'll divide both sides by 6 because 6 is a factor of the 18 and the 12. So if we have 18a plus 12b is equal to 1, and we divide both by 6, then we get 3a plus 2b is equal to 1/6. And if a and b are integers, then 3a and 2b must also be integers. So 3a plus 2b will be an integer as well. And now we can write our conclusion, which is that this contradicts the statement that 3a plus 2b is equal to 1/6. So therefore, there exists no integers a and b where 18a plus 12b can equal 1. Okay, so we'll try one more example. And in example 3, we've been asked to prove that if n squared is even for all integers, then n is even. So our first step is to assume the opposite, where we say there exists an odd integer, which we'll call n, such that n squared is even. So for our workings, we'll let n equal 2k plus 1. So this must be odd because 2k is even, and again, when we add 1 to an even, we get an odd. And this is where k is an integer. So n squared will be 2k plus 1 squared. And when we expand this out, we get n squared is equal to 4k squared plus 4k plus 1. We can factorize that with 2 from 4k squared and 4k. So we get n squared is equal to 2 lots of 2k squared plus 2k. So this, by definition, is even. And when we add this 1 to it, we know that this is odd. So our conclusion, this means that n squared must be odd, which contradicts the original statement. So if n squared is even, then n must also be even. If you have any questions about proof by contradiction, please leave them in the comments below. I'll be happy to answer them. And you can download the full lesson and worksheet from our website, mrmathematics.com. There's a link in the description below. Thanks for watching and take care.